Perfect. Great session by Akansha. So we really, you know, bogged down with it. Just could attend the last few parts of it, but yeah, it was a really awesome session. Actually, so you set up the standards over there on top. My session would be a bit boring, so no practical over there, but just a bit of theory, to set up the basics of what Akansha is already, shared with you a few things over there regarding artificial intelligence, but a lot of people has a higher level of understanding for artificial intelligence, and then we'll talk about what data does and how we can, program that data to help us reach that AI sort of things, and understand the pretty basics of what AI is and what AI configures over there for us. So just talking about big data analytics and the products in Microsoft Azure that has been introduced to help us do that analytics of our big data. So we might have heard about a lot about big data nowadays, and talking about data over there, is something that we think everybody's collecting our data. Government organizations. We've seen a lot of movies as well. you know. So especially Black Hat and other movies that we've seen that government organizations are collecting our data. Our privacy details are going, and before the COVID situation as well, we might have seen those, heard those, new words, PII, personally identifiable information, GDPR, Facebook having calls, Mark Zuckerberg be called to UK, and a lot of things before the COVID situation happening, all these things. So what is actually data? What do you understand by data? So you can put it at every different level, right? You can say that it's 0 and 1s. You can say it is text. You can say it is, at that particular level. What level I put it at is basically the meaning of the data is raw facts, right? But I put it at a level that you call my name like Farhan. Farhan is basically text over there, but yeah, it's a name. You don't know whom it belongs to at the moment, right? So it's just a name that you have, Farhan, over there. My telephone number, it's just a number. It's a telephone number, but you don't know whom it belongs to at the moment, right? So, similarly, my email address, my postal address, all these things are just over there for you as data. Right. But then when we put, OK, this is Farhan, this is his email address, this is his telephone number, right? That comes up to information, right? So we build that information with that, right? And then when we have a lot of information, we create databases, we clean that tables, we clear that data, and we bring it into knowledge, right? We build those relational databases. So, Akanksha said about structured databases, non-structured databases. So in an organization, if you're working, you get data sources from multiple places, right? And if you're collecting data, like data from, like nowadays data is getting collected from our routers, from our IP cameras. So, Internet of Things. So a lot of data getting collected. So you need to build that relationship between the data. You need to understand what data is. So ingesting that data, bringing that data in, data lakes are there, Azure data lakes are there, but then understanding that data, collecting that data in a format that, we will be able to make sense out of. And then if we are able to make sense of, then we can ask the computer to make sense out of it as well. You're getting the point, right? So what we are doing is we are becoming wise, or we're making the computer wise based on these algorithms that we have written, right? So chat GPT or other artificial intelligent things, like for example, Akanksha showed you a model that where the picture was able to understand, and give you context over there. Google has created these algorithms long time ago, Google Lens, right? You will take a picture of a plant and it will tell you what plant it is. You will take a, you will speak in some language and then that would translate into another language, Google Translate, right? So all these things have been there for a long time, but what is it? It is basically, an algorithm that has been written at the back end to understand. So what ChatGPT is doing now is doing just search that Google does for you, right? And tries to understand, what you are trying to say based on understanding, language understanding. You do all these courses, IELTS and other things, English language courses. So it's just trying to understand your language, the psychology of human being. So whatever we have studied so far, it's only able to take that knowledge, not able to create the knowledge itself, right? So that is the job of machine learning then. That is where machine learning will step up, right? So now Microsoft has created algorithms for machine learning as well, right? But again, I would say that is not machine learning, but it is AI. Like for example, insider risk management. Anybody's heard about that? Compliance, lot of risks that we are happening, especially in Australia. I'm from Australia, so especially in Australia, we've had these attacks, recently. I'm not sure about other countries, but they, you might be, a lot of cyber attacks going around these days because a lot of people are working from home post COVID. Right. So all these cyber attacks happening, a lot of insider risk management, because people are saying that all these attacks are caused, either there is an intentional user or unintentionally. Previously there were mostly unintentionally, people used to write their passwords down and stick it on their desks. So what will happen, right? You can guess, but unintentionally, intentionally as well, these things are happening now. So to protect that, like for example, if somebody's been issued a warning letter, if somebody, so it can connect with your CRM, it can connect with your HR systems, right? Somebody's been issued a warning letter, somebody's been issued a termination letter, or if somebody's himself or herself has submitted themselves a resignation, then if they're trying to copy large amount of data onto a USB, or if they're trying to connect large amount of data, to save it on OneDrive or Dropbox, so you can connect with all these applications, right? And then get that data, and you will not be able to transfer that data, even you will be blocked from that. So machine learning is happening at the back end, that you've submitted this resignation. So this is just an algorithm, right? If conditions, like my son solves that Rubik cube, right? Rubik's cube, everybody's been playing with that Rubik's cube. I can't solve it, but my son solves it, right? So he's seen that algorithm on the internet. He saw that, okay, turn this right, turn this left, turn this back, turn this down, So all these things that, it is in English language. You can translate that in programming language and explain it to the computer, right? Create that algorithm, become wise. Computer becomes wise. 2 plus 2 is a simple algorithm that we explain to the computer. Computer becomes wise. So now what we're talking about, that data that has been ingested into the systems, right? We analyze that data. Previously, we used to write those SQL queries, right? They have given us the name of big data analytics now, right? It's just a name change, guys. Like, internet has been named into the cloud. A lot of things have been introduced, infrastructure as a service, platform as a service. Previously, we used to have those websites as well stored on someone else's PC, right? You still access those websites from someone else's PC because it's our website, but we're not creating a web application server over there on our end. We're giving it to someone else. So we're hosting our websites on someone else's server. Previously, we used to do it as well, right? Now we're hosting applications and we're calling it platform as a service, right? And then we have given those virtual machines that we used to create on a server as well. We've created them and called them infrastructure as a service. So that's the cloud, right? So a lot of name change that is happening. Microsoft has that habit of doing, name changes. So, if something is called something different, just look it up, that what was it called in the past as well, like Microsoft Defender, Azure threat protection. So if you're in the security field, then you might know these buzzwords as well. But yeah, so becoming wise based on the data. So that's what we're going to talk about, mostly analyzing these data workloads that we have, right? So understanding the data that we've brought in. So, like Akanksha in the previous one talked about how we can bring that data in, how we can ingest that data. There is structured data, there is unstructured data, right? So you might have, read-only systems that store vast volumes of historical data or business metrics as well, right? So you might have data that is there, financial data that is there. You might have some compliance reasons which you want to store that data for a long period of time, right? Retention policies are there, right? So like, for example, in Australia, we have this retention policy that will be saving that, data for about 7 years at least. So similarly, government organizations, Department of Defense, they have to store their data. Universities, your degrees, your, all that systems, all that data that needs to be stored for a long time. So all that data has to be there, right? So analytics can be done on any different kind of data at any point in time, right? Or, we can create snapshots of these data of where we want to take that. Like, for example, I want to research only on 2012, what happened in that year, right? Or when there was a Spanish flu, right? I want to just, because of the COVID situation, now we've, analyzed that data. So what they like Siri is listening to me right now, big data. So they're collecting all that data. So it's always listening, right? So, you know, analytical information, the example could be a report on your monthly sales, right? That you have. So, data lakes are very common in that modern data warehousing scenario. So where a large volume of non-relational data must be collected and analyzed. So that's what I was talking about. You have that data that is coming in is, of different kinds. So you have that in Oracle, you have Cosmos DB, tables, files, all these different data. So, we have to create that data warehouse, which is an established way to store data, in a relational schema that is optimized for read operations, right? So, we can, and then we can create our queries, question the data to support reporting and data visualization, right? So, we need to, there are two different kinds of analytical processing as well. One is the online analytical processing and one is the online transactional processing of that data as well. So analytical processing is the aggregated type of data storage that is optimized for analytical workloads that we have, right? So data is imported, aggregated, so that aggregations of this numeric facts, like for example, if you have sales revenue or number of items that are sold, can be pre-calculated across different dimensions you have. Like for example, the product dimension, you have the date dimension, you have the geographical location. So based on that, you will be able to get that particular, look at sales in different ways, right? So that's what you can do over there, right? So different kinds of aggregations that you can do at different levels, which will allow you to drill down or up, for example, total sales by region, total sales by city, total sales by country, or total sales by date, year, month, quarter, so different aggregations that you can perform on your data as well. There are different types of users as well. So you have data scientists, data analysts, business users, end users, financial users. So now Microsoft has that focus on a lot on business users, how they will be able to analyze data or analyze the data within Cube. So we have created this Power Platform, right? We have the Power BI as well, where we can ingest data. So these are different services that we have. So if you go to the next slide, Microsoft Cloud Services. So these are most commonly used services that we have within Azure. So, we have Azure SQL, again, platform as a service, right? So, SQL servers, we used to install it ourselves, but now we have a place where we can use that Azure SQL from, a centralized location from which we can create that database over there. Right. So Azure SQL, you have a fully managed platform where, it works and you will be able to, start working on Azure SQL. You don't have to set up SQL server. You don't have to set up servers, just directly start up a server and then start working with that. Right. Other things, you can create a virtual machine and then, of course, you can, download an SQL server. If you want to use infrastructure as a service and manage the SQL server by yourself, you want more flexibility, right? So as we go onto the cloud, the more we use the cloud, the less the flexibility, right? But easier it is because they are managing it and we are just using it, right? So if we want more flexibility and we want to use it ourselves, we create an Azure VM and then we run Azure SQL. So these are some data stores that you have: Azure SQL, database for open source. You have MariaDB, MySQL, PostgreSQL. So some open source data sources as well that you have. Azure's Cosmos DB, right? Non-relational database system that you have, Azure Storage, through which, you have those storage accounts, and then based on that, you will be creating files, blobs, tables, queues, binary large objects, mostly that are being used. So for example, if you're creating virtual machines, the VHDs at the back end are stored as page blobs, right? And then if you're storing images, that are block blobs, right? and then you have you have logs over there for as well that are being stored within blobs. So different kinds of blobs, and then we have hot and cold storage. If it is transactional data, then it is hot storage. If it is archival data, then you will store it in a cold storage. So that kind of things as well that Azure supports over there. So we talk about Azure technologies, right? And then data engineering and analytics that we have the Azure Data Factory. Right, so we work with that data factory where data pipelines are created, so you can ingest that data into different storage. Then we have stream analytics. So stream analytics is that data. So you might have seen the movie Skyscraper, right, where data was coming in immediately. There is real-time data that needs to be there, right? So fire alarms were there with scanners, and the reporting were coming, which floor that had the fire, which room had a fire, right? Where you can go to protect yourself. So Internet of Things are sending real-time data. We have real-time process, online transactional processing that I was talking about, right? Where we need real-time data. So for example, ATMs or banking data that we have, we need that real-time data. Health systems, right? Blood pressure, all these things we need real-time data. So Azure Stream Analytics supports that. We will be able to ingest real-time data processing, right? Synapse Analytics, integrated end-to-end analytics. So you can create pipelines where you can bring that data. You can use SQL servers. You can use Apache Spark as well, right? So Apache Spark is there within this. So this is basically an open source Apache Spark service that you can use. You can use different languages within that to explore the data. So Data Explorer is there through which you will be able to explore the data or question the data and ask the data, and then preview the data as well in different formats as well. Data Explorer, real-time data analysis for logs and telemetry. So, if you have that, similar Data Explorer that you've been using in Azure Synapse Analytics, where we will be able to analyze logs and telemetry data. So for example, as I said, AI. So where is the Microsoft getting all that data which we used in information risk management, right? So the data logs coming in from there. So there is a warning letter that has been issued, or distributed denial of service attack that somebody's trying to attack us. We will get that data from the logs. Right, so log analytics workspace is very important over here. That is another service through which we collect all the logs there. Right, so all these services that we are using, we will collect all that data in a workspace. So like, for example, if you're using Azure Synapse, we have to create that workspace over there at the backend through which we will be able to use Azure Synapse as well. Then we have Azure Databricks as well. So another open source service, another Microsoft service of Apache Spark. So Microsoft Spark basically helped Microsoft in building this particular product. I'll be talking about differences between Synapse and Azure Databricks. There is a lot of similarities that they work through within together. So, it is also being used for analytics, data processing, but mostly Databricks is used for machine learning, right? So machine learning, like for example, simple example that you log into Hotmail. Every day you log into Hotmail from your desktop or your laptop, right? Another day you start logging in from a library, or go to the post office, or sorry, not post office, library, or go to the airport, so you log in with different things over there, right? So that's where you will be able to understand that, okay, you're not logging in from the same device. So it will give you raise a flag that, okay, you're using a different device. Do you want to log in? Or you can configure different things with Azure Active Directory over there at the back end, that do you want to log in with this? If not, then you have conditional access over there. Do you want to block the user? Do you not want to allow them to use these devices? So machine learning algorithms can be created, and you can use Azure Databricks for that, with different kinds of data. Azure Purview is a data governance thing, very new, not very new, but a couple of years, during the COVID situation, they decided to move on to a different thing as well. So for data governance, data mapping, discoverability of the data governance is basically, how to use that data. So for example, if you have credit cards in the organization, right? Definitely you get customers' credit card details, finance department, somebody in the finance department would have access to it as well. You don't want that access, sensitivity labels, you have to assign them sensitivity labels so that everybody don't have access to it. Customers data, salespeople can also see customers data. It would be in the same customer table. You don't have a different customer table for different users, right? So there is the same customer table. Salespeople will have a different view. Finance department, one person from finance department also, from another person will have a different view. So different people will have different views. So that is data governance. We manage that through Azure Purview. Map that data, discover that data, find out where that data is being used within the organization, where the data leak happened, right? So discoverability. Azure HD Insight, another tool, right? Apache open source platform. So very similar to Azure Databricks and Azure Synapse. But yeah, we use it for a different thing we'll be talking about in the next few slides. Power BI, again, some of you might have used Power BI if you've been there and might have heard about it. Definitely Power Platform is, the buzzword these days. So business intelligence, right? So you get the data, extract the data, you transform the data, and then you load them into beautiful charts. You might have used Excel. You might have used other reporting tools like SSRS or, other reporting tools. There are Tableau and Qlik as well, but Power BI, because it's Microsoft, it's easier to use. Microsoft is in the market because everybody's using it, right? So, and I'm Microsoft, certified trainer for more than 10 years. So I will portray that Microsoft's product is one of the best ones. But yeah, so it's basically there for business intelligence, extracting the data, transforming the data, and loading the data. What is the difference between Excel and Power BI? You can create charts in Excel as well. Of course, what you can do is over there, you can create interactions between charts, different kinds of charts that you have. You will be able to create interactions between those charts. So when you click on one chart, you will be able to see the result in the other chart. So for example, if you've changed the slicer or you've changed the filter over there to that particular year, you'll be able to see in all charts that are there on that particular dashboard for that particular year or for that particular product or for that particular category, right? So Power BI helps us do that. Plus one more difference, that is one of the major differences without which we can do with Excel as well, right? We can't create relationships in Excel. Right? We don't have relational data in Excel. We can create relationships in Power BI. We can bring data from the web. We can bring data from Oracle. We can bring data from SQL. We can bring data from SAP, multiple different sources, and then we can create relationships over here. We can create data sets and then we can create. In Excel, we can use up VLOOKUP and HLOOKUP formulas, but, different than Power BI. So a little bit about data lake storage. So first of all, we need to have that storage where we will be storing the data. So data lake storage helps us, store that data. So multiple different types of data, as I said previously as well. And, what do you call it? Talked a lot about data storage. So we'll move on from this particular slide and move on to Power BI a little bit over there. So data modeling, visualization, this is one of the easier tools that we use for Microsoft, right? Bring data from Excel, bring data from the web, SQL, Azure Synapse, cloud files that you have, CSV files. So, you have a free tool now. That's what the advantage of moving towards the cloud is, that you've got these free tools now. So you can work on the free tools. But if you want to share it with someone, then there is the Power BI service. You publish it to the Power BI service, and then you can use it on a web browser, or you can use a Power BI mobile app. So there is a mobile app where you can use these models as well. So you can bring in multiple data sources. In this Power BI desktop, there is a Power Query editor as well. So if anybody knows mQuery language, again, it's a query language, questioning the data, right? So before bringing the data, we use that query language so that we can, make that data smaller, because the size of the file, if the size of the file increases, right? The more the data we bring in, millions of rows, trillions of rows, sales data. So if we bring it in, again, the file size over here would increase, which would be, a disadvantage for our desktop. But then again, we want to push it to the Power BI service. So there are two different kinds of licenses, Power BI Pro and Power BI, which is the other one? Right? So Power BI Pro and Power BI, blah, 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 blah. Sorry, forgetting about it. So, but there are two kinds of licenses where you get the Pro, which is a shared capacity, and then Power BI Premium. Sorry, yes. So when you get the premium capacity, so the second one is Premium, where you get the premium capacity, so that you can, put it on the cloud and you have your own capacity where you can see your report. So if millions of users are connecting with that service, the advantage of getting onto the cloud is scalability as well, right? So for example, if you go to the Apple website, how many users would go to an Apple website every day? 5,000 users. But when an Apple mobile comes out, there are about 1,000 users or million users going onto that website, and the website goes down every year. Right. So now being in the cloud, they don't have to maintain that infrastructure for 365 days to maintain a website, right? For millions of users. Of course, Facebook, that's another story. But Apple, nobody goes to their website, right? There's nothing interesting over there, right? You don't want to do their training, right? On Apple products. So, you go on, million users for a week or a month, they don't have to maintain that infrastructure or pay anyone to upload their website for 365 days for supporting million users. That is where scalability comes in. So that's one of the major advantages of cloud, right? Horizontal scaling, vertical scaling, you add another. So if the computing power is above 80%, add another. If it is above 80, again, it is still above 80%, then add another. And you can create automation rules over there. So these are also rules artificially intelligently. You are adding scaling over there. Right? If it is below 20%, then go down. So similarly, Power BI service, if there are multiple users, they will be, you can use Power BI Premium service, right? If you think that your reporting will be used as much as, that, millions of users are connecting over there, or even thousands of users, then, it's better to get that premium capacity over there. Right, so we can use that Power BI service as well. So we have that Power BI query over here, right? As I said, we can reduce the size of the data when it comes in, before it comes into Power BI desktop. And then if we want to maintain or, change any of the data or clean that data again, cleaning that data is very important. DAX, we can use DAX, data analysis expressions, another formula language like we have in Excel, a formula language. It has more than 250 extra formulas, time intelligence formulas where we can predict the future, what will happen based on the data, that we have already. We can create formulas over there, what will happen in this quarter, what happened previously as well. So, multiple formulas that we have, which we can use with DAX as well. So modern data warehousing. So that's what Akanksha was talking about as well. So it's a generic term, which describes the infrastructure and processes that are used to support large scale data analytics. Right. So there is, these solutions that we have over there, which combines conventional data warehousing, which supports business intelligence, right? Which typically involves copying the data from transactional data stores into a relational database. And you have to create that schema that is optimized for querying and building these multi-dimensional models with techniques used for the so-called big data analytics. So where you will be able to see large volumes of data, which are in multiple formats, are batch loaded or captured in real-time streams that you have, and stored in a data lake from which distributed processing engines like Apache Spark are used to process the data at scale. Right, so you will be able to. So, this is the basic architecture that so data ingestion and processing. This is the analytical data store. We can create a model and then we'll be able to visualize the data. So this is basically how modern data warehousing works over there. So data ingestion and processing pipelines, create pipelines in Azure Data Factory or Azure Synapse Analytics. So we have Azure Synapse Analytics as a full-fledged system over there that can help us, work on these pipelines, getting the data, understanding the data, and then even, creating that how we will use that data as well. So I said I will be explaining what is the difference between Synapse and Databricks that we've worked with. So Synapse is basically is a limitless analytical service that brings together that enterprise data warehousing and big data analytics. So it gives you the freedom to query data on your terms. Either you can use your serverless or on demand or provisioned resources that are at scale, right? And it brings these two worlds together. So with a unified experience to ingest, prepare, manage, and serve the data, for immediate BI and your machine learning requirements as well, right? So, of course, as I said previously as well, they do overlap, but they're not the same thing, right? Databricks is pretty much a managed Apache Spark, right? Whereas Synapse Analytics is a managed SQL data warehouse, right? So if you're doing machine learning development, Databricks is preferred over there, right? So, because Databricks has these machine learning optimized run times, which includes, the popular libraries like TensorFlow, PyTorch, and these GPU enabled clusters, right? So, these are managed and hosted versions of machine learning flow, which is provided in Databricks by default, right? So, and then there is enterprise level security for your data as well, right? So you can use Azure Machine Learning from Databricks support for GPUs, with tight integration and CI/CD as well, integration and development on full environments, right? So you can use that over there. For ad hoc data lake discovery, you can use both Synapse and Databricks. For real-time transformations, Databricks is preferred again, because there is a Spark structured streaming service as part of the Databricks, which is proven to work seamlessly, right? And then, you have the Z order clustering. So when you use Delta, join optimizations, etc., so you can use that over there as well, right? For SQL analysis and data warehousing, Synapse is preferred over there. So because it's a full data warehousing, which allows full relational data modeling, right? Stored procedures, SQL, TSQL, if you have that experience, then you're recommended to use Azure Synapse over there, right? So, some basic differences that we have over there with Azure Synapse Analytics as well. So on Azure, large scale data ingestion is best implemented by creating these pipelines that we have. Coming back to this slide, right? So you can create and run pipelines using Azure Data Factory, or you can use the same pipeline engine in Azure Synapse Analytics. So if you want to manage all of the components of your data warehousing solution in a unified workspace that you have, right? So pipelines use linked services to load and process data, and then enhancing you to use the right technology for each step of the workflow that you have, right? So for example, you might use an Azure Blob Store linked service to ingest and input data set, and then use services such as Azure SQL to run a stored procedure that looks up related data values, right? So before running a data processing task on Azure Databricks or Azure HD Insight, or you can apply custom logic using Azure Function as well. So, multiple technologies that you can use together as well, right? So these are all linked services, which with you can create these pipelines using Azure Functions. You can create that logic as well, and finally you can save the output data set in a linked service such as Azure Synapse as well. So you can bring that data again back to Azure Synapse Analytics over there. So if you're using that one service, it's better to learn that one service and use that one service for ingestion and creating pipelines as well. So, as previously talked about, we've talked about that there are three common ways to implement an analytical data store as well, right? So a data warehouse, which is a relational database, which is the data that is stored in a schema that is optimized for data analytics. So rather than transactional workloads, commonly the data from a transactional store is denormalized into a schema in which numeric values are stored in central fact tables and which are related to more one or more dimension tables that you have, right? That represent entities by which the data can be aggregated. So, for example, like you might have a fact table that might contain sales order data, which can be aggregated by customer, product, store, and time dimension. So we've talked about that as well, right? So how you will be able to see that through the star schema. So we have that star schema, which can be often extended into a snowflake schema, right? By adding additional tables related to those dimension tables. Like, for example, rather than creating hierarchies over there in that one table, we can, have that product table being extended to categories and subcategories, right? Or that time table or that date table to quarter, months or years. So, rather than creating hierarchies over there, we can add those different other tables as well. Right, so that's totally up to you how you structure your schema or how you create. So data lake is basically a file store that is usually on a distributed file system for high performance data access. So, you have technologies like Spark, Hadoop, which are often used to process queries on the stored files and return data for reporting and analytics, right? So these systems often apply a schema on read approach to define tabular schemas on semi-structured data files at the point where the data is read for analysis without applying constraints. So, you can also use a hybrid approach, rather, using any one of the two, right? So you can combine features of data lakes, data warehouses. So, so if in a lake database or data lake house, the raw data is stored as files in a data lake, and a relational storage layer abstracts the underlying files and expose them as tables, which can be queried using SQL pools in Azure Synapse Analytics or Polybase as well, which enables you to define external tables based on files in a data lake. And other sources as well. So you can use, other query languages that you are comfortable with, and extract that data as well from there. So, querying is there. And as I talked about, these are the major tools that we have. So, three main services that we have, where we can use them as analytical store, right? So I've explained Synapse Analytics as well, of where you can use it. You can use Synapse SQL, Apache Spark, Synapse Data Explorer. So it has a Azure Synapse Studio, which you can use, for analytical services. So which includes the ability to create interactive notebooks that you can create, in which Spark code and markdown content can be combined. So, if you've worked with notebooks previously, these are basically, scripts that you can write and run, and then with explanations over there, right? So that you understand of what is happening within your environment as well. So Synapse Analytics is a great choice when you want to create a single unified analytical solution as yours. So as I said, just that whole solution is there for you to run, right? So you can run that whole solution with that one product, which is all in all, right? Which gives you all the services. You will be able to integrate the data. You will be able to create pipelines with data flows, and then you'll be able to ingest and process the data. And then, of course, you will be able to analyze that data as well. Again, Azure Databricks is an implementation of the popular Databricks platform that we had previously. So it's built on Apache Spark, which offers native SQL capabilities, as well as, the workloads that are optimized Spark runtimes for data analytics and data science. So if you are further interested in, using machine learning, right? Again, it has an interactive user interface through which the systems can be managed and data can be explored. Again, in interactive notebooks that we have similar, but we can use it on multiple cloud platforms, right? So you can use Azure as a Databricks as your analytical store if you want to leverage existing expertise with the platform, or if you need to operate in a multi-cloud environment or support a cloud portable solution as well. Right, so cloud portability, if you want to use, you want to use different cloud environments, AWS, Google Cloud, then, consider using Databricks as well over there. Again, HD Insight is an Azure service that supports multiple open source data analytics cluster types. It's not as user friendly as Synapse Analytics or Databricks, but again, it is a solution that is there. So it can be a suitable option if your analytics solution relies on multiple open source frameworks, or if you need to migrate an existing on-prem Hadoop based solution to the cloud as well. So this is where you can look at all the services that are available in the cloud as well. So if you Azure Analytical Services, right? So this is where we will be able to find analytical products. AI machine learning. So these are Azure Cognitive Services featured. Where is that? Analytics.
Okay, so I'm just gonna interrupt you, Farhan.
5 minutes, yeah.
You have another 5 minutes. So yeah, I mean the session's been great. I mean there's a lot of architectural value to this. So yeah, I can
Yes,
see.
a lot of
Yeah,
theory.
yeah, a lot of architecture. Like I mean, obviously the from looking at from a from an overview perspective, you would need to sort of get into the architectural details and how the reporting and the data warehouse capabilities sort of come together and build that entire landscape. So yeah, that's great. So
Thank you.
yeah, I think in another 5 minutes we'll have another break and then we like yeah, you can go to the next
Sure.
side.
Sure.
Okay.
So this is where you will be able to find all the products that you have. I've sent the link in the chat window as well. I think, Misbah would be sharing it into your live question and answer feed as well. So if you have any questions, you're more than welcome to ask. This is my LinkedIn. So if you want to connect with me on LinkedIn, you're more than welcome. So /in/Farhan-Usman. So yeah, hopefully you enjoyed the session and thank you very much.